All right, so let's go ahead and prove the vector dot product in 2 dimensions today. Okay, so the vector dot product in 2 dimensions states that if we have two vectors, we'll call them u and v, and we'll establish the components u1, u2, and v1, v2. Okay. So the claim is that u dotted into v is equal to the magnitude of u times the magnitude of v times the cosine of the angle in between them. And then, of course, by definition, it's going to be u1 v1 plus u2 v2. Okay? Let's go ahead and prove this. Shouldn't be so bad. I'm thinking the law of cosines as a proof, to use it as a proof, and because this looks a lot like the law of cosines, doesn't it? It really does. Okay, so let's establish a couple of vectors here, u and v, in the plane. Okay, so here is vector u. And let's put in here also vector v. Okay, both positioned with their tail at the origin and their tip in the first quadrant without loss of generality. Now, let's also establish the following vector here. Okay, this is going to be vector u minus v. Okay. Now, the angle between them here, theta, is going to come into play. Now, if I consider the law of cosines, we're going to have the following. The magnitude of this squared, so by the law of cosines, which we've proven in a past video, by the way, so we are going to be relying on a more fundamental statement from trigonometry for which we have an established proof. Okay, you can prove the law of cosines using, of course, the Pythagorean theorem, and the Pythagorean theorem you can prove in a multitude of different ways. The video we have up is a basic geometric proof. Okay, it's one of the most fundamental proofs out there, quite frankly. Okay, so by the law of cosines, we have the magnitude of this squared is equal to the magnitude of, we'll say the magnitude of u squared plus the magnitude of v squared minus 2 magnitude of u magnitude of v cosine of theta. All right, that would seem like a logical way to proceed. Okay, we're going to break it up into components, and I think we're going to be good to go with this. Okay, so u minus v, what is that? Well, okay, it's just the following vector, u1 minus v1, that's the x component, u2 minus v2, there is the y component. So we're going to take all of that and square it. All right, and then we've got the magnitude of u squared. So the magnitude of of a vector is the square root of the sum of the squares of the components. Okay, so it's simply going to be u1 squared plus u2 squared all squared plus, and then same thing here, right? So v1 square root of v1 squared plus v2 squared, all of that squared, minus 2. Let's maybe zoom out one more step, and then we're going to have magnitude of u, magnitude of v. So magnitude of u, okay, and then the magnitude of v, and then of course cosine of theta. Okay, good. Okay, well we're getting closer, aren't we? All right, so let's go ahead and simplify this. This is simply going to be the following. Okay, so u1 minus v1 all squared plus u2 minus v2 all squared, all of that squared. Okay, now this is just going to be u1 squared plus u2 squared here. This is going to be v1 squared plus v2 squared here. Over here we're going to have minus 2, and then these are going to stay pretty much as they are. Okay, we still got cosine theta here. All right, now this radical and this power 2 are going to cancel out, and I'll just go ahead and now expand all of this. So expanding all of this, I'm going to get u1 squared minus 2u1 v1 plus v1 squared. Okay, expanding this, I'm going to have u2 squared minus 2u2 v2 plus v2 squared. Over here, of course, u1 squared plus u2 squared plus v1 squared plus v2 squared minus 2 magnitude u1 squared plus u2 squared. We can zoom out one more step. Magnitude v1 squared plus v2 squared, cosine of theta. Okay, we can subtract a u1 squared from both sides, subtract a u2 squared from both sides, a v1 squared from both sides, a v2 squared from both sides. Okay, and now I can divide everything through by negative 2. And we're done. Yeah, that wasn't that hard at all. So dividing both sides through by negative 2, I'm going to have the following. u1 v1 plus u2 v2 is equal to square root of u1 squared plus u2 squared times the square root of v1 squared plus v2 squared times the cosine of theta. And of course, that's simply going to give us u1 v1 plus u2 v2 is equal to the magnitude of u times the magnitude of v times the cosine of theta, and we are done. Okay, a little bit easier than I thought it was going to be. I thought we would maybe be at that a little longer than we were, but I hope you found this helpful, and of course, as always, let me know if you have any questions, comments, and concerns. We love proven math statements around here, physics statements, so please do not hesitate to submit recommendations of future content. Have a great rest of your day, and we will see you in the next video.